Anchor handlers or anchor handling tug supply vessels are very powerful ships that deploy, recover, and shift a subsea mooring pattern. These vessels are normally seen working with offshore installations. Anchor handlers are used as multipurpose workboats in the oil and gas offshore field. They can perform towing operations, rig moves, execute general supply duties by carrying dry and liquid cargo such as cement, mud, fresh water, fuel oil, etc. for the offshore installations as need be. Anchor work for rigs, barges, semi-submersibles, construction barges, etc. can be executed with the help of these kinds of vessels. These vessels can perform efficiently in toughest sea conditions and also in ultra-deep waters. Either one or a fleet of anchor handlers cooperate with each other and work as a unit. During the demanding operation of anchor handling of an offshore installation such as a drilling unit or even a semi-submersible rig, these offshore vessels are assumed to be service vessels when assisting the vessels whose anchors are to be worked upon. Anchor handling tug supply vessels are super-strengthened, purpose-built and different from the harbor tugs, or even the ocean-going ones. The newer anchor handling tugs are built to survive the toughest conditions of the sea, keeping in mind safety, comfort and complete efficiency of the crew. Anchor handling vessels have superior bollard pull and a higher engine rating, which makes them powerful enough to be utilized for specialized jobs such as anchor handling. They are fitted with a combination of multiple thrusters at the bow and the stern, with twin-screw controllable pitch propeller systems providing tremendous vessel handling features that allow such vessels to work in any sea condition. Anchor handlers have a large amount of strengthened deck space astern of the accommodation areas, allowing even the largest of the anchors, heavy wires, chains, buoys and other related equipment to be stowed and handled. Anchor handlers have an extremely powerful multi-drum system, catering twin winches, one each for towing and anchor handling purposes. This is apart from the combination of other spare drums and work winches used especially for towing and deep water anchor handling. Anchor handlers can stow a sufficient amount of anchor chain on board due to the availability of larger capacity chain lockers. Anchor handling involves a number of special marine operations. The high tensions experienced in chains and wires may cause high heeling moments and may cause high transverse and/or astern movements of the anchor handling vessel. The vessel's motion through the water may also be affected by high hauling speed on the anchor handling winch or as a result of any loss of bollard pull. The vessel may be pulled astern at speed by the tension in a heavy anchor arrangement. Any simultaneous loss of thrust, for any reason, on the vessel may lead to a rotation which would lead to considerable extra transverse forces. Environmental conditions will also influence the operations. For these reasons, the vessel's stability needs to be closely monitored. Prior to sailing, a document must be displayed on the bridge, where it is visible to the navigator on duty, to show the acceptable vertical and horizontal transverse force/tensions to which the vessel can be exposed. This should show a sketch of the GZ curve and a table of the tension/forces, which give the maximum acceptable heeling moment. The calculation should then be made to show the maximum force from the wire or chain, acting down at the stern roller and transversely to the outer pins, which would be acceptable without taking the vessel beyond the angle stated above. If a deep water move is planned, the weight on the stern roller can be hundreds of tons, which will be applied at a distance off center line according to the setup of the towing pins. This will add to listing moments and stern trim. This type of vessel usually suffers reduction of stability, and the deck edge is immersed earlier as the stern trim increases. A flooded deck at this point, for example from a breaking wave, can also cause a temporary reduction in stability. Fuel consumption from double bottoms must also be considered along with use of freshwater and ballasting condition. Before any ballasting operation is carried out, the operator should be aware of the immense effect on stability of having any tank slack, particularly transverse roll reduction tanks. Communications between all parties are vitally important. The more people who know what is going on, the safer the job will be. Briefings should be shared by as many as possible. Contingency plans should be discussed before the operation. Before sailing, a procedure book is produced with all relevant information and should be supplied to the vessel on confirmation of contract. A towmaster and marine rep are appointed by the oil company involved, and a pre-rig move meeting and safety briefing should be held on board prior to mobilization. If this is not possible, rig move procedures are to be transmitted to the vessel and agreed by towmaster and vessel crew. Relevant risk assessments should be reviewed and discussed. A new risk assessment should be written for any unusual operation being planned. Before the operation, particularly where two vessels are working together, a communication plan for the operation must be established, which in particular ensures an effective and coordinated action in the event of any unintended incident. A toolbox talk should be held with the ship's crew to instruct them of the intentions, and to emphasize the safety aspects. About 1 hour prior to job commencement in the field, tank status, freeboard, and calculated GM information is to be transmitted to the owners. Leaving port, a navigation package is usually installed on the bridge. This displays information such as the current and/or proposed anchor patterns as well as pipelines, cables, etc. on the seabed. Positions are given in northings and eastings, so are not transferable to radar or electronic charts using latitude and longitude. Deck equipment should be checked. A good supply of punches and hammers are needed. Some breakage of these must be expected, especially with Kenter links. Buoy lassos, for recovering buoys from the water, should be inspected if they are needed, along with boat hooks, and plenty of split pins. To release undesired tension, the winches are fitted with emergency release mechanisms. These are not instantaneous releases, but allow a fast payout of the wire from the winch drum. Where a quick release system is fitted on any winch, personnel should be familiar with their operation and effect. The vessel's crew should be instructed in the procedures for emergency release methods, and a notice posted on the bridge giving the vital information for operation of emergency winch stops, releases, and hydraulic operation. There are various types of anchors, with different characteristics. We are not going into anchors here, but the stepbrace, shown here, is popular. There are also two types of Bruce anchor, still in use, the Twinshank and the FFTS. And pipelay barges usually use AC-14 anchors. Semi-submersible rigs use 8, 10, or 12 anchors and chains to secure them. In a normal location, they will have chasing collars set on the chains. The internal oval size of these is about 1,000 millimeters, and they weigh about 1.5 tons. A 60-meter wire, known as the PCP, is attached to this, often with some chain in between. PCP stands for Permanent Chain Pendant, Permanent Chasing Pennant, or Permanent Chaser Pendant. Calculations are made to verify that the forces involved are within the capacity of the vessel. They must take into consideration the weight of the anchor lines, and the anticipated force or tension which may occur in any phase of the operation. If, at any time during the operation, the vessel experiences greater loads or tension than anticipated in the plans, the anchor handling operation must be discontinued, and the gear and equipment relieved, or emergency released. The vessel must not connect the anchor or towing gear directly to her winch unless she can handle the load and dynamic conditions alone, based on her permissible capacity according to the stability and load calculations. A rig crane passes the end of the PCP to the stern of the anchor handler, with a spare sling for the deck crew to catch with a boat hook. They hook the tugger wire on and pull the PCP between a pair of open toe pins to a wire stopper. Then the crew let go the crane, and connect the work wire from the winch, using an 85-ton or other appropriate-sized shackle and split pin. Using the navigation system supplied, head towards the anchor, while paying out wire, including the PCP, to 1.4 times water depth. Come onto the anchor slowly, less than 1 knot. With the rig's approval, bring the ahead power up to around 50 tons, and once the rig has slacked down the chain tension, wind in on the winch, until the anchor is under the stern roller. Reduce ahead power, and the rig will wind in chain. Do not let the vessel drift over the next chain. A record is kept of all vessel positions throughout a rig shift, so later analysis of moves is possible. An offshore anchor buoy is a specialized device used in marine environments to provide mooring and anchoring solutions for various offshore structures such as floating platforms. It serves as a connection point between the structure and the seabed, ensuring stability and preventing drift.